So welcome back to another numerical computing video. This is Fashi Yar Khan from B3, and today we're gonna learn a new technique to finding the root, and this is a close bracketing method, and this technique called bisection method. So without wasting any time, let's begin. So let's get started with the bisection method. Bisection method is the easiest way to find the root, but it's a longer way to get the root. It's take a lot of iteration. So let's get example of function of x is equals to x cube minus x square minus 1, and first we have to find 2 points where the function of x are changing their sign. Because this is a graph, the one point is upside down and one part is from the above of the line x. So this is a minus sign, this is a positive sign. So the point root lie on between these sign. So let's put x is equals to 1, and we get function of 1 is equals to 1 cube minus 1 square minus 1, we get minus 1. And similarly put x is equals to 2, and we get function of x2 is 3. So these 2 points 1 and 2 are the points where in between root are lying. So first we have to take the average of these 2 points. 1 plus 2 upon 2 is equals to 1.5, and put this value is in this function, and we get 0.125. Now fill the table. How we fill the table? X is equals to 1, x is equals to a, and it's 1. B is equals to 2, and c is equals to 1.5. Function of a is minus 1, function of b is 3, and function of c is 0.125. So how we replace the value? 3 and 0.125 have the same similar sign. The 3 is also positive, 0.125 is also positive. So function of c replace the function of b, and c replace b. How it works? 1, 1.5, 0.125, and minus 1. So how we get the c? By taking these two average, taking the average of these two values, and the value we get, put this value on the function of c, and we get the function of c. Let's check how it's worked. 1 plus 1.5 divided by 2 is 1.25. Now put 1.25 on function of x. So answer cube minus answer square minus 1, we get minus 0.609. Now the function of a and function of c have the similar sign. So function of c replace the function of a. So it's minus 0.609. It remains similar because it's only have the value who has a positive sign, 0.125. So function of b remains same, 1.5, but function of c replace function of a. C replace a, it's 1.25. So now root is lying between these 2 points. Now we done the third iteration by taking these two average. We get function of c, and put this value in this equation, we get the function of c. 1.25 plus 1.5 divided by 2, we get 1.375. Put this value in the equation. Answer cube minus answer square minus 1 is minus 0.2910. so it's again have the negative sign, so it's again replace the value of function of a, and c replace a. B remains similar because it has similar sign. As we continue till we get the function of c is equal to 0. and when we get the 0, function of x is equals to 0, function of a, b or c is equals to 0, we get the root. Okay, so let's implement this method on Python language. So without wasting any time, let's get start the coding. So without wasting any time, let's get started with the code. First we have to define a method named Bisection Method that take 5 parameters: function, a, b, tolerance level and max iteration. Function is the function, the target function. A, b are the intervals, the in which where the root is lying between these 2 points, and tolerance is the acceptable error, and max iteration is the number of iterations that are allowed. So this method returns two things: the number one, the approximate root, and the other one is the number of iterations that are performed. First we have to initialize a if condition in the root in the given method. That's if function of a into function of b is greater than 0, that means the function value at the interval endpoint must have opposite sign. So it's a value error. Then iteration is equals to 0. It's this starter of a counter that start from 0 every time it iterate 1 in it. So first time its iteration is equals to 0, second time is 0 plus 1 is 1, iteration is equals to 1, third time is 2, every time it is increase 1 in itself. So when we initialize a while condition, that takes two arguments. First is b minus a upon 2 is greater than tolerance level, and iteration is less than max iteration. So if these two conditions are true, the while loop should be run. Otherwise it's out of the while loop and it's return root and iteration. Okay, how the while loop run? So let's see. First we have to initialize a formula of midpoint. Midpoint is equals to a plus b upon 2. It is a value of 2, value of average. Then we initialize the if else condition. First we have to, if function of midpoint w is equals to 0, it's written midpoint and iterated. Else function of midpoint into function of a is less than 0, b is equals to midpoint, and else a is equals to midpoint. If these two conditions are not true, the else condition should be run automatically. Then it print iteration plus 1. That means iterate the value of 0 plus 1, and root is equals to midpoint. Okay, the midpoint should be the root. So then again every time it iterate the formula, root is equals to a plus b upon 2, and the method should return root and iteration. Then we give the question in then we initialize another method that passes the question, in which we have to return the question, and then initialize two variables a and b that are the interval points, and then call the function, then print the result. Let's check how it's work. So it's work. At the 19th iteration we get the root at 0.1.465571, iteration number 19. So hope you guys understand what I'm trying to say. So see you in the next video. Allah Hafiz.